Hello, I am Dr. K.S. Badarinarayan, the Principal of MS Engineering College. I extend a warm welcome to you for a discussion on the transportation problem, finding out the basic feasible solutions using Vogel's approximation method, also known as the VAM. First, we find out the initial basic feasible solution using the VAM or the Vogel's approximation method, and we find out the solution, optimum solution using UV method. So for understanding purpose, I consider a small problem wherein I have got 4 warehouses and 4 destinations with the requirements and availabilities as shown in the diagram. So in this particular diagram or the matrix, you also observe that we have the cost of transportation from W1 to D1 and etc. have been shown here in the matrix. The criteria in Vogel's approximation method is that we find out the row penalties and the column penalties. The row penalty is nothing but the difference between the minimum and the next minimum. So if you look at the minimum in this particular first row is 3 and the next minimum is 4. So the difference between 3 and 4 is 1. Similarly, the difference in the second row, minimum is 1, the next minimum is 2, therefore the difference is 1. That is nothing but the row penalty. Now if you look at the fourth row, the difference between the minimum 2 and the next minimum 9 is 7. So that's how the row penalties are calculated. Now the column penalties. The column penalty is nothing but the difference between the minimum and the next minimum. The minimum is now 6 here and the next minimum is also 6. Therefore, it is taken as 6 minus 6 is equal to 0. So this is how we compute the row penalties and the column penalties in the beginning. Now once you calculate the penalties, we choose the maximum penalty. We choose the maximum penalty, and in the maximum penalty either it may come in the row or in the column. So in this case the maximum penalty occurs for W4 row. So we see that particular row and find out the minimum cost. The minimum cost is 2. So therefore this cell, that means we start transporting the items from W4 to D4. So that becomes the criteria for selection of the cell for which the allotments can be made. W4 to D4 is a cell. Now what is our next allotment we are going to have? So in this, if you look at the availability and the requirements, the requirement is 5 units whereas the availability is 10. So therefore we can give 5 units. 5 units can be transported from W4 to D4, thus satisfying the requirement at D4. So we cancel that particular column and reduce the availability at W4 to 5 units. Next, we go for recalculation of the penalties again. We go for recalculation of the penalties. So if you look at now the difference between the minimum and the next minimum in the first row, the minimum is now the minimum coming here is 3 and the next minimum is 6. So the difference is 6. The minimum here is 1 and the next minimum is 7. So therefore the difference is 6. That is the row penalties. So this is how we calculate the row penalties and the column penalties once again. And for again we take the maximum penalty and the minimum cost cell. So therefore W2 and D3 become the cell for allotments. Now the availability at W2 is 7 units and the requirement at D3 is 10. So what is that we can transport is 7 units. So 7 units are transported from W2 to D3. Now thus satisfying the availability at W2. That means the entire availability at W2 is exhausted. Therefore we cancel that particular row. And at D3 our requirement comes down from 10 to 3 units. Now the next, again we go for recalculating the penalties. So the penalties are recalculated. Now we take the highest penalty. The highest penalty again is 7 and the least cost is 3. So W1 D3 become the cell for allotment. Now if you look at there, the availability is 5 units and the requirement is 3 units. So hence we go for an allotment of 3 units from W1 to D3, so that we get 3 units there transported. And if you look at the availability at W1 reduces from 5 to 3. And now the requirement at D3 is completely satisfied. Therefore, we go for cancelling that particular column. Once again, we go for recalculation of the penalties. Now the difference between the D1 and D2 is made, and difference between D1 and D2 is made, and similarly the row penalties and the column penalties are calculated. Now if you look at the difference between 6 and 7 is 1, the difference between 5 and 6 is 1, the difference between 9 and 18 is 9. So therefore we take again the highest penalty, and in that least cost. So W4 to D2 becomes our next cell for allotment. So we have again here 5 units with us, that the availability is 5 units and the requirement is 5 units. Therefore the 5 units are transported from W4 to D2 and we mark that particular 5 units there. Now this satisfies the availability at the W4. So we are going to cancel W4 or D2 is the next question. Now here what we do is, actually we do not cancel both row as well as column, we cancel any one of them. Either D2 column is deleted or W4 is to be deleted. So we delete, let us say, D2 column, and we are left with W4 is not cancelled. But instead of cancelling that, what we do is, since the availability and the supply is simultaneously satisfied, we are going to just add an epsilon value in the W4 row in order to get the initial basic feasible solution. And that next cell, when you look at, W4 to D1 becomes the cell for allotment. Now that epsilon is allotted there, where epsilon is nothing but is equal to 0. Now once again we go for calculation of the penalties and start allotting for the next row or the next column, that is W3 to D1. If you look at, the availability is 8 units and you have the requirement of 10 units. Therefore 8 units can be transported from W3 to D1. Thus the availability at W3 is satisfied, so we are going to cancel that particular W3 row, and we are now left with only one particular cell, that is W1 to D1 with only 2 units. So we are going to transfer from W1 to D1 2 units, and that's how, if you look at now the row totals, so 2 plus 3 is equal to 5, 7, and here 8, and here the total 5 plus 5 is equal to 10. Now similarly the column totals, if you look at, it is 8 plus 2, 10, here it is 5, 3 plus 7, 10, 5. So total availabilities is matching with the total requirements, and that's how we get this particular matrix after removing all the lines there. So we get a matrix here. Now if you see here, we have got 4 rows and 4 columns. So if you take n plus m minus 1, so we have the 4 plus 4 minus 1 is equal to 7. And if you look at the number of cells allotted here, it is also 7. That means to say that we have a basic feasible solution. Now with this basic feasible solution obtained by Vogel's approximation method, we go for next UV method. So in the UV method, what we do is u and v, that means if the variables u we are going to assign for different rows. So we have 4 rows, therefore we will have u1, u2, u3, u4. So we have 4 columns, so we will have v1, v2, v3, v4. Now if you observe the particular cells, so there are some cells where the allotment is there. Wherever the allotment is made, they are called as basic cells. Wherever allotment is not made, they are called as non-basic cells. So for the basic cells, the relationship Cij is equal to ui plus vj will hold good. For the non-basic cells, we compute the net evaluations Cij minus of ui plus vj. Now these net evaluations, whatever that you are going to have for the non-basic cells, all the net evaluations must be greater than or equal to 0. If it is greater than or equal to 0, then we have an optimal solution. If not, we proceed with iterations. Now let's find out what will be the u1's u values and the v values correspond to the equation what we are going to have Cij is equal to ui plus vj. Now if you look at the first cell, that is the first row in the first column, so we have C11, that is first row and first column. C11 is equal to u1 plus v1, that is Cij is equal to ui plus vj, where I is equal to 1, j is equal to 1. So if you look at now, the C11 value is 6, so 6 is equal to u1 plus v1. Now if you assume u1 is equal to 0, then we get v1 is equal to 6, that is v1 is equal to 6. Now similarly, we check out C13, that means w1 d3, 1 I is equal to 1, j is equal to 3, that is C13 is equal to u1 plus v3. Now we know that u1 is equal to 0, therefore v3 is equal to 3, so this is 3. So we find out v3. So similarly, for the second row and the third column, C23 is equal to u2 plus v3. So since we have got C23 is equal to 1 is equal to u2 plus v3, v3 we just now calculated, so that will be, when you substitute, you get u2 is equal to minus 2. So similarly, the u's and v's are calculated for this entire matrix. So once we calculate the u's and v's, next we go for finding out the net evaluations. So the net evaluations are nothing but Cij minus of ui plus vj. That means for the first, let's say, non-basic cell here, w1 d2, that is 1 2, the first row and the second column. Now we have Cij is equal to 7, that is C12 is equal to 7, minus of u1 plus v2. So we have u1 is equal to 0 and u2 is equal to minus 3. So that is 7 minus of 0 minus 3, which is nothing but 7 minus of minus 3. So that is equal to, you will have, let's say here 7 minus of minus 3 is 10. Okay, so this is 10. That means it's positive. Now let's take this as a positive value. So we are not going to write down the exact values, we can just write down the positive values, positive figures. Now similarly, for the first row and the fourth column, C14 is equal to 4, the value is 4, and u1 is equal to again 0 and v4 is equal to minus 10. So that is 4 minus of minus 10 is equal to 14. So that's how this value is also positive. Now if you calculate in the similar way, all the net evaluations, we have calculated the net evaluations. Now all of them are positive except this particular cell, that is W4 and D3. Now for W4 and D3, that is nothing but C43. C43 is nothing but 10 minus of 12 plus 3. So that is equal to 10 minus of 15 is equal to minus 5. So that turns out to be negative. Now since this is negative, the solution is not optimal. So therefore, now the rearrangement of the cells has to be undertaken. That means this particular cell, we are going to have some value here. That means there will be an addition in this particular cell. Now if there is an addition in this cell, the row values are going to change because you have got only 10 availability. So that means if I add something here, I have to subtract something anywhere, either in this cell or in this cell or in this cell. Now let us say that we connect this cell to this cell. Suppose if I add something here, I have to subtract something here. Suppose if I subtract something here, now again the column totals are going to change. So I have to again add something. Now assume that I am going to connect from this cell to the next cell here. So that means I have subtracted something here, I am going to add something here, so it will be plus. So whatever that I have subtracted and added means the column total will remain same. Here I have added, here I have subtracted means the row total remains same. Now here if I look at the row, I have added something here, therefore I have to subtract something from the next cell what I am going to select. Suppose if I select this cell, so I am going to plus something, that means I am going to minus something here. So again I have done minus, so I will connect from this cell to this cell. Now let us say, so I have subtracted something here and added something here. So that means to say the entire thing is now connected by a rectangle. That means I am able to connect these cells and see any modifications that can be done in this particular assigned values. Now if you look at now, this is plus, this is minus, and plus and minus. So if you look at minus, it is epsilon here and you have a value 3. So between these two the minimum is epsilon, because epsilon is nothing but a value which is equal to 0. So the minimum. That means to say in my next iteration what I am going to do is I am going to add epsilon here, subtract epsilon here, add epsilon here, subtract epsilon here. So epsilon is nothing but 0, therefore it's not going to have any changes in this particular value. So by doing so in my next iteration, if I look at now with a neat sketch here what I have shown here, it is plus epsilon 2 and then 3. So now I am going to I have connected this through a lines, a box. Now by adding epsilon and subtracting epsilon from the allotted elements, now what rearrangement I will have is that it will be 2, 3, 7, epsilon, 5 and 8. So you can notice that epsilon has moved from this particular cell to this particular cell, right? It's not going to have any other effect other than that. Now if you now again recalculate the u's and v's, again we have to recalculate the u's and v's. Now in this case it is 6, so we got a 6. So 6 is equal to u1 plus v1, yes, that is 0 plus 6 is equal to 6, satisfied. 3 is equal to 0 plus 3, satisfied. 7 is equal to 1, here it is 3, it is minus 2, that means 3 minus 2 is equal to 1, that is also satisfied. So if you look at now, for all the basic cells, the relationship Cij is equal to ui plus vj will hold good. Now for the non-basic cells, again we calculate the net evaluations Cij minus of ui plus vj. Now for this particular cell, now let us say w1 d2, that is 1 and 2, I will have Cij is equal to 7, so that's what I have written here. So 7 is equal to 7 minus u1 is 0 and v2 is minus 3. So that is 7 minus of minus 3. So that becomes 11 again, the same correction here. It will be 7 plus 3, it is 10. That means it's positive. Now similarly, if you go for the next cell, that is C14, the value is Cij is 4 minus u1 and v4, that is u1 is 0, v4 is minus 10. So minus of minus, that becomes plus. So 4 plus 10 is equal to 14. So that is why it's marked as positive. So similarly, I calculate for all the non-basic cells, I find that we have got positive. That means all net evaluations are positive. Once the optimal solution is obtained, what we do is now we calculate the optimal cost. The optimal cost is calculated like this. The number of units that is transported from W1 to D1 is 6, rather than 2, and the unit cost is 6, so therefore the cost will be 6 into 2, 12. Similarly, from W1 to D3, the number of units transported is 3, cost of transportation is 3 per unit, so therefore 3 into 3 is 9. Similarly here, it will be 7 into 1, here it is 8 into 6, here it is 5 into 9, epsilon into 10, 0, 9, 5 into 2 is 10. Now all this is tabulated in this particular table, and we get a total cost of 131 rupees. I hope you have understood how to calculate the optimal solution for a transportation problem. Thank you for watching. Please subscribe to MSEC's channel.